1, 2, 3. Okay, we start with Assalamualaikum warahmatullahi wabarakatuh to Dr. Adnan bin Rosli. Okay, today me Muhammad Ibn Rashdan bin Muhammad Rashid with my team Muhammad Izzuddin bin Muhammad Syahidi and Muhammad Afiq Iman bin Muhammad Fauzi would like to introduce to you what is the electric driven intelligent braking system, which is a combination of regenerative and hydraulic braking system. Next, we go to introduction. Okay, moving a car have a lot of kinetic energy. Okay, and when brakes are applied to slow a vehicle, all of that kinetic energy has go to somewhere. In a conventional power brake system, the internal combustion engine car, especially when the car have a brakes, they have a solely friction based and converted the kinetic energy to wasted heat. But in the electric driven intelligent braking system, which had controlled by ECU to control the ball screw arrangement, there is no direct load when we apply the brakes. The motor operated by the brake for providing the braking energy is more controlled, and uniform braking force is helped to recover braking loose when a generative braking system is used. Next, methodology and working principles. Electric driven intelligent brake, or short form is EDIB, utilize the vehicle electric motor to directly operate the brake cylinder. Okay, when the driver step on the brake pedal, the necessary braking force is maintained while the hydraulic pressure of the friction brake is controlled to help maximize the energy regeneration of hybrid motor. For your information, the electric driven intelligent braking is used in hybrid cars and electric car. Okay, this system controls the regenerative brake and friction brake to support both of these requirements. And this system also controls the reactive force from the pedal in order to unify the feeling when the stepping down on the pedal and the sense of the acceleration. Next, the example of electric driven intelligent braking system, as we can see, there is the electric driven intelligent brake unit. How the generative braking system works, as known as an energy recovery mechanism that slows down a moving vehicle and converting its kinetic energy into a form that can be used immediately or stored until needed. In this mechanism, the electric traction motor uses the vehicle momentum to recover energy that would otherwise be lost to the brake disc as heat. Regenerating braking uses the electric vehicle motor as a generator to convert much of the kinetic energy loose when accelerating back into stored energy in the vehicle battery. And then, the next time when the car accelerates, it uses much of the energy previously stored from the generating braking instead of tapping in further to its own energy reserve. For the example ways to know how it works, how the generative braking works, for when the car have acceleration, the car is using the power from the battery, and the battery have convert the power to inverter, and the inverter supply the electric power to the electric motor generator to move the car. Okay, when we apply the braking, or we just move from our leg from the throttle pedal and step the braking system, braking pedal. As we can see at the right picture, the electric motor is become the generator, which is convert the energy to the inverter, and the inverter will charge or convert the energy to the battery, and the battery will have the new energy, which the electric motor generate the negative torque in reverse direction, which mean in the reverse direction, the motor will be the generator and will generate the energy to convert to the inverter, and inverter will charge to the battery. Okay, next, efficiency. Efficiency of the generative braking process varies across many vehicles to 60 to 70% efficient. The generative usually lose around 10 to 20% of the energy when converting that energy back into acceleration. There's no 70%, that means braking system will give a 70% range increase. This is not going up to range about 100 miles to 170 miles. This simply means that 70% of the kinetic energy lost during the act of braking can be turned back into acceleration later. Effectiveness. The effectiveness of the generative braking is measured how much it can increase your range and make a very significantly based on factors including driving condition, terrain, vehicle size. Driving condition is a large impact of effectiveness of generative braking when stop and go traffic city in the highway commuting. This is because we have repeatedly braking. We will recapture a lot of energy than a simple drive for hours without touching the brake pedal. In the terrains also play their parts. When we had a downhill driving, it will generate a much larger amount of energy due to the long braking periods. In where long downhills, the generative braking can use it nearly consistently to regulate speed while consistently charging the battery. The component of generative braking system and their function. For the AC or auto current, or we know as a motor or generator. Generative braking works exactly the opposite way. When the vehicle is with forward momentum want to slow down, the flux wave must rotate slower than the rotor. To do this, the frequency of supply to the stator is reduced, so the flux wave rotates slower than the rotor. When the flux wave travels slower than the rotor, the motor runs with negative slip, since during the generation the motor is traveling faster than the flux wave. The relative force on the motor and stator reverse. If the torque reverse, the force reverse, the motor begins a generate, or as we know, a generator. It is important to realize a AC induction motor requires a power source to generate because the magnetic field must be induced on the conductor of the rotor for a force to be created. This is the example of motor. Okay, the next component is the inverter and converter. This device is used both electric vehicle and hybrid to manage their electric driven system. Along with a built-in charge controller, the inverter or converter supplies current to the battery pack for recharging during regenerative braking and it also provides electricity to the motor or generator for vehicle propulsion. Both hybrid and electric vehicles use a relative low voltage DC batteries, about 210 volts, to keep the physical size down. But they are also generally use highly efficient high voltage, about 650 volts, or auto current motor or generators. The inverter and converter is unit to grasp how these divergent voltage and current types work together because of the use of transformers and semiconductor and the accompanying resistance encountered. For example, the converter is a unit that supplies a current to the battery pack for the recharging during generative braking. This is important components in the generative braking system. See, as you can see, there is the inverter and converter. Electric car batteries. Yes, in the electric vehicle system, we must have a battery that store energy system in the electric cars. The battery type can vary depending on if the vehicle all electric or plug-in hybrid electricity. Current battery technology is designed for extended life, typically about 8 years or 100 miles. As usually in electric vehicle cars, we usually use lithium ion batteries, which have the high power on off ratio, high energy efficiency, and good in high temperature performance. This means the battery have a lot of energy to the car to give to the car and can travel further on a single charge. Lithium ion batteries also saves discharge rate, which means they are better than other batteries at maintaining the ability to hold full charge over time, and this part of battery are recyclable, making this battery is good choice of environmentally conscious. The methods of electric vehicle battery charging. In all electric vehicle, the electric vehicle charging station also have it in the and the plug-in hybrid electricity also have. In generative braking also have in the electric vehicle, but in the internal combustion engine just only have in the hybrid electric vehicle, because the internal combustion engine use the petrol. This is the example of lithium ion batteries in electrical car. In the right, on the left picture, we can see the mechanism inside the battery, and the right picture we can see the location of the lithium ion batteries. Okay, next, anti-lock braking system, ABS, is also used in electrical vehicle system, which had use it in electric vehicle system. They have a cooperate with the generative braking system to stop the car. Okay, the anti-lock braking system, ABS, is a safety anti-skid braking system that used on the vehicle. It's preventing the wheel from the locking up during the braking and maintaining tractive contact with the road surface. ABS operates much faster rate and more efficiency than most driver could manage. ABS system is also cooperated with the generative braking system, which it controls the hydraulic fluid to working as a braking system. There's an example of the anti-lock braking system ABS. There's a component of the ABS in the car. Okay, that's all for me. Thank you.
Okay, now is the conclusion. The conclusion of this electric-driven intelligent braking system is: it is a good system that all cars should have because a motor operated the brake for providing the braking energy. A more controlled and uniform braking force is applied, since it's ECU-controlled. This helps to recover braking losses when a regenerative braking system is used. It also prevents the braking energy that is extracted from the engine and at the same time the energy that lost in stopping the car. Based on the technology functionality, the system produces natural and adequate braking force that corresponds to the operation. This makes the system more reliable to the car. The regenerative braking is an energy recovery mechanism that slows down a moving vehicle or object by converting its kinetic energy into a form that can be either used immediately or stored until needed. This shows that the system should have in many cars, because it also improves the overall efficiency of the vehicle. Regeneration can significantly extend the life of the braking system, as the mechanical parts will not wear out very quickly. And when the next time the car accelerates, it uses much of the energy previously stored from the regenerative braking instead of tapping in further to its own energy reserves. Based on all of the information, the system is a must to put into all vehicles nowadays, because it have its own benefits towards the car, safety and others. Therefore, we all hope that this technology will improve much better, or there will be much more reliable technology invented in the future, since it also has its own cons. Thank you.
Assalamualaikum warahmatullahi wabarakatuh. We continue about hydraulic braking system. A hydraulic braking system transmits brake pedal force to the wheel brakes through pressurized fluid, converting the fluid pressure into useful work of braking at the wheel. A simple single-line hydraulic layout used to operate a drum and illustrated in the brake pedal relays the driver's foot effort to the master cylinder piston, which compress the brake fluid. This fluid pressure is equally transmitted throughout the fluid to the front disc caliper pistons and to the rear wheel cylinder piston. As per the regulation, a separate mechanical parking brake must be incorporated with at least two wheels. This provision also allows the driver to stop the vehicle in the event of failure of the hydraulic brake system. This is a picture about a car when used to brake to stop the car. Okay, so this is a various component in the car, like pipes, master cylinder, disc brake, drum brake, wheel cylinder, the mechanic of a hydraulic braking system, and last, brake master cylinder. So we can Okay, the new residual pressure master cylinder blockhead. The master cylinder has a cylinder pressure chamber and a reservoir chamber. The reservoir takes up any fluctuation in the volume of the fluid in the system due to temperature change and for a limited amount of fluid leakage. The middle region of the master cylinder piston has a reduced diameter and is always full of fluid. Rubber lips are fitted at the both ends of the piston to prevent leak of fluid. A high-pressure capsule known as the primary seal is fitted to the return spring end of the piston, and a low-pressure ring seal known as the secondary seal, which slips into a recessed groove around the piston, is fitted to the push rod piston end. A thin washer is placed between the capsule and the piston to prevent the cap being drawn into the recuperation hole drilled around the piston head. A rubber boot enclosed to push rod end of the cylinder to keep the cylinder bore free from the dust. Next, drum brake use a reservoir pressure check valve at the end of the pressure cylinder opposite the push rod. Once the brakes are released, this check valve develops a low line pressure of 49 to 88 kPa, which offer the following service. Number one is provide a minimum pedal-free travel by opposing the brake shoe traction spring. It maintains a light contact of the wheel cylinder seal lips with the cylinder bore to avoid entry of air. It prevents the re-entry of fluid into the master cylinder during the bleeding operation. They ensure a fresh charge of fluid at each stroke of the brake pedal and a complete push of the air from the system. Unlike the brake, this brake must have no residual pressure in the pipeline. This permits a complete release of the pad from the disc, avoiding overheating of disc and rapid wear. To achieve this, a small restrictor hole is provided in conical check valve. This gives complete pressure relief, and the system can still be cleared by fairly rapid pumping of the pedal during bleeding. Okay, this is about master cylinder. Residual pressure master cylinder. Look here, when you push pedal brake to stop a car, the piston also push refuse to go to the disc brake and drum brake to stop a car. Okay. Non-residual pressure master cylinder Girling. The master cylinder also contains the pressure chamber and fluid reservoirs. The piston operates in the pressure chamber where the reservoirs permits additional fluid to enter into or return from the system to maintain a constant volume during temperature change and any seepage of fluid in the system. This is non-residual pressure cylinder pump, master cylinder. Okay, the cast iron piston in the master cylinder is shaped like a cylindrical plunger with a hollow stem at the one end, a spring retainer in the form of the timber shaped steel prising which feed of the piston stem and clip in place. The valve stem has a enlarged head which rests in the hollow piston, and the valve itself is housed on the valve space near the reservoir's inlet port. A rubber ring acts as a lid seal and is fixed at each end of the piston. The rubber cup, called the primary seal, is installed near the return spring. The cup is subject to the line pressure and form a flute-type piston end. A secondary seal, installed at the pushrod end, prevents any leakage of the fluid from the rear end of the piston through the primary seal. A rubber boot placed over the back end of the master cylinder and around the pushrod prevents the cylinder wall from dirt contamination. Next, we go through about compression barrel master cylinder. A compression barrel master cylinder incorporates a stationary primary recuperation seal held in the body, with the plunger moving through the middle of this place and apply pressure to the fluid. There are four small radial compensation ports in the plunger which, when the brakes are released, bypass the recuperation seal to allow movement of fluid between the reservoirs and the cylinder. When the foot pedal is placed, the recuperation seal covers the radial compensation port so that the fluid is trapped in the pressure half of the pedal. The brake pipelines is consequently pressurized. You can see this is compression barrel master cylinder. Next, wheel cylinder choose expanders. Hydraulic braking system having drum brake use wheel cylinder choose expander unit. The wheel cylinder transmits the hydraulic pressure to the brake shoes later through the single piston system, which is common in front drum brake vehicle. All of the double piston type that are incorporated in a rear drum brake. Double piston wheel cylinder choose expander. The unit incorporates a cylinder body, two piston seals, seal spring and a retainer spring if cup type seal are used, rubber dust boot, and sometimes separate expander tabs. The cast iron with cylinder body has an extended spigot portion for fitting into a hole in the black plate to which it is secured usually by two studs. This attachment with the back plate must be sufficiently rigid to absorb the braking torque reaction during application of brake. A cylindrical hole in the body accommodates to the piston seal and seal spring and a retainer ring. Annual grooves form at both ends of the cylinder to install the rubber dust boot. A bleed screw valve is located at the center of cylinder, usually at the highest point for purging of air from the chamber. This is about a rear wheel must cylinder pump. Okay. The two pistons installed in the wheel cylinder convert the hydraulic pressure into brake juice tip fluid. The diameter of these pistons are based on the required by load for the front and rear brake. The piston outer and normally receive the shoes toe web for acting directly against the shoes. Sometimes the shoes are pushed outward by push rod or screw tape or abutment located between the piston and the shoes tips. In case of cup seal, a retainer spring pushes the cup seal against the piston head and the cylinder walls. Consequently, the fluid does not slip past the piston and air does not enter the wheel cylinder when the brakes are released. The ring lip seal sits in groove around the piston, and the natural elasticity of the rubber preload the seal lips radially against the bore. A rubber boot or cap are fitted over each piston explode end. The safeguard the cylinder walls from brake lining thus ended. Single piston with cylinder choose expander. A single piston with cylinder unit are normally used on front drum brake to provide the higher braking efficiency. Two single piston units are fitted diametrically opposite each other. The single piston unit expands one choose against the drum and acts as the anchor abutment for the other choose, thus perform the dual function. If the upward movement of both the single piston unit is in the direction of forward rotation of the drum, the combination is known as a two-leading choose brake. Similar to the piston unit, the single piston unit are bolted to the back plate. This unit works in similar way to that of the double piston one, except that the cylinder has a blind end to the form the anchor abutment for the other shoes. Either the ring seal or the cup seal which a seal separate and retainer spring to use seal the piston. Single cylinder pump. Okay. Combined hydraulic lever rear wheel choose expander. In this case, the cylinder bore support both inner and outer piston. The outer piston use a press steel dust cover well to it and is grooved to carry a rectangular cross-section rubber dusting. The inner piston use a cup seal with a seal spreader and a retainer spring to preload the cup seal against the cylinder wall in the release position of the brake. The of tapered end of the crank lever is housed in the triangular slot from in each piston. This lever located and pivoted on a pin in the body. Uh, this is combined hydraulic or lever rear wheel choose expander. Okay. Separate rear wheel parking brake mechanism. In the parking brake choose expander, the hydraulic foot brake cylinder body is bolted to the brake plate. A piston at each end actuates the choose. A link strut brush the two choose, one end connecting against one choose web and the other end acting as the pivot point for the parking brake lever attached to the other choose. Two alternative lever layouts are present in it is per, perpendicular to the choose in and is parallel to the choose in. The cable is joined to the free end of the lever. The cable pull to the application of the handbrake pivot the lever. The strap pushed by the lever one way, actuates the leading choose and lever the trailing choose in the opposite direction. The expanding force is sharp equally between them as the links that float between the two choose. So this is called separate lever or called handbrake. Okay. Uh, the working calculation for generating braking system pressure. Pressure is a function of the required clamp load and the piston area. Remember, on an opposed piston disc brake is only the area on one side of the disc. So this P means system pressure equals C brake clamp load over A total piston area. Next, brake heating. Stop energy. The energy dissipated in a stop is the sum of energy from three sources: kinetic, rotation, rotational, and positional. Kinetic energy. Assuming the stop is formed, the test speed down to zero the kinetic energy. So this is how to calculate about brake heating. So Ke is kinetic energy in bracket joules equal 1 over 2 or half m total vehicle mass kg and v test speed minute per second. Rotational energy. The rotational energy is the energy needed to slow rotation part. It varies for different vehicles and which gear is selected. However, taking 3% of the kinetic energy is a reasonable assumption. Personal energy. The personal energy is the energy gained or lost by stopping on a hill. So this is a working calculation for rotational energy and personal energy. PE mean personal energy equal M total vehicle mass, G acceleration due to gravity, S is loop or percent tan incline angle. Alright. That's all. Thank you.
Okay, now is the conclusion. The conclusion of this electric-driven intelligent braking system is: it is a good system that all cars should have because a motor operated the brake for providing the braking energy. A more controlled and uniform braking force is applied, since it's ECU-controlled. This helps to recover braking losses when a regenerative braking system is used. It also prevents the braking energy that is extracted from the engine and at the same time the energy that lost in stopping the car. Based on the technology functionality, the system produces natural and adequate braking force that corresponds to the operation. This makes the system more reliable to the car. The regenerative braking is an energy recovery mechanism that slows down a moving vehicle or object by converting its kinetic energy into a form that can be either used immediately or stored until needed. This shows that the system should have in many cars because it also improves the overall efficiency of the vehicle. Regeneration can significantly extend the life of the braking system, as the mechanical parts will not wear out very quickly. And when the next time the car accelerates, it uses much of the energy previously stored from the regenerative braking instead of tapping in further to its own energy reserves. Based on all of the information, the system is a must to put into all vehicles nowadays because it have its own benefits towards the car, safety and others. Therefore, we all hope that this technology will improve much better or there will be much more reliable technology invented in the future since it also has its own cons. Thank you.